Assalamualaikum, this is Muhammad Ghous and this is the lecture 2 of quantum relativity hypothesis. Now, in this lecture, we're going to talk about superior quantum system and its applications on general relativity on this field equation. G mu v equals k T mu v plus the dark energy term. Now, let's use the formula in the previous lecture we have derived like this. Observer operator n equals n minus 1 means the observer observing the wave function has one dimension or has one dimension higher than the observed object to make its wave function collapsed. Now, in this topic, we are going to talk about how we can convert a lower dimensional object frame into high dimensional. Basically, making the SQS converting into the final frame. Now, according to string theory, on which many scientists like Michio are working, which states that there are 11 dimensions. Now, we use the same topic here by using the tensor transformation rule like this for beta x. By using this transformation rule, we derive it. Now, first of all, we explain it in terms of contracted tensor, a lower dimensional object in terms of contracted tensor. Like, let's say we're talking about a book as a vector to illustrate or to make its mapping with high dimensional frame. We simply say that the other component is basically contracted like this mu v. Here the v component becomes equals to v basically, and we have simply contracted it because we can't observe it in our daily life, but we can feel its magnitude in the form of dark matter and dark energy, which we cover later in our lecture 3. So let's begin by converting the stress energy into high dimensional stress energy. But in this whole process, we have simply contracted it. Now let's say this is T, alpha, beta, and gamma are three-dimensional, and this is mu, v, and 0. The other term is contracted basically, and x, x. Now here we use these three terms alpha, beta, and gamma with respect to the components of our space-time. X, 0. Now here this component is basically scalar or contracted with respect to the gamma term. Now let's derive the function. Now according to this hypothesis, let's say x alpha, we are talking about x alpha, it is equals to this mode square, means a lower dimensional object in higher dimension is equal to the probabilistic nature of the lower dimensional object. Means let's say we're talking about an object in the SQS, it has x, y, z, or let's say some dimensions n minus 1, and the total dimensions are n, which is outside the SQS. Now to make it probabilistic, we have simply written it like this, like as a wave function, its modes squared. So by applying this relation, let's see what we got. Alright, T alpha beta equals to T mu v differentiating x alpha beta gamma partially with respect to mu v and the contracted term at which mu v equals w to make it contracted, and by applying the functions we get t mu v differentiating x mu its probabilistic square, x v its probabilistic square, and x contracted x term describing its magnitude, its wave function's probabilistic nature, modes squared, partially with respect to x mu, x v, and x contracted term. Now, how it is contracted? As I have said it earlier, we have simply made it equals to mu v or mu v equals to w to make it contracted, because we only feel its magnitude in the form of dark matter and dark energy, but we don't feel its direction because we are lower dimensional beings. But the lower and higher dimensional beings with interact with each other, and I will explain this whole topic in my lecture 3, that how they interact. Now, after this whole differentiation, apply the power rule, and this whole process will become something like this: T alpha beta gamma equals to T mu v as a function of, now we have 2x mu after differentiation and applying the power rule, we have 2xv, 2x0 component as in terms of wave functions, which will becomes 8x mu v and the probabilistic zero term becoming the wave function. Now what if these both x contains constant as the constant to define stress, oh sorry, the curvature of space-time. So if we include a constant here with x, let's say k here, means let's say we are talking about tv equals to, by applying a k it becomes equals to gv. This is just an example. So if we use constants here, like the Einstein constant k equals 2.070 multiplied by 10 power minus 43, the Einstein constant. Now if we are talking about, let's say this is an example of a constant. Now if we are talking about constant, it simply describes each vector relation with the relation of stress energy with curvature of spacetime, like its variables, applying the, oh sorry, and by applying constants here we make something like this, like it is a function of these two variables and this is a function of these variables, and applying the constant we get its relation with spacetime's curvature. Now let's say if we apply the constant, what will happen? In order to convert it into space-time variables like x mu equals to, by applying k it becomes equals to g mu. Let's this is an example, and here we have scalar magnitude which is basically contracted and has also a k constant effect. That's how dark matter work, and that's why we have extra mass. We feel like galaxies that is tightly packed with each other due to the extra scalar mass called dark matter. So by applying this concept, we get something like a Neil-Bohr concept. We get something like that: 2n k to n, and n as a function of n minus 1. Oh, sorry. Right here, t n. We get this equation, something like that. Now here the n term explains the number of dimensions. Now let's say we are talking about mu v to basically it is describing indices, number of indices we used to explain dimensions. Now let's say if we apply the indice number 2, how it looks like. N becomes equals to 2, how it looks like. Let's calculate it. If we are talking about the Einstein constant, it will look something like this. 2 n becomes equals to 2, 2 power 2, k 2 multiplied by 2, and it is describing the variable n minus 1. It looks something like this. And here's a contracted version of this. That's why we have written n minus 1. And we also use the contracted version which has effects on this constant, and by making it a function of, recite it again, um, simple version like k4 x mu 0 as a function of t mu v equals to, basically here we apply the zero scalar. How it looks like something like this: t alpha beta gamma. Which is simply stating that we can only make lower dimension into higher dimension if we make our variables as superpositional to make to for the mapping of coordinates, like x mu has a mapping with x alpha as a superpositional factor. That's how it looks like. By calculating it, we get 7.33 multiplied by 10 power minus 170, and that will give us a series of constants. But how many indices we can use? I mean, is infinite limit? No, it has a limit. It is not infinity. Right, like let's say t mu v, it is describing 40. If we use 7 more indices, 7n, we get 11 dimensions used in string theory. Now I have defined it in terms of tensors rather than topology. And by making it contracted and applying it on the constant which reveals its magnitude, we can calculate its magnitude by simply contracting it because we can't see it. And that's how I simply make its nature, its properties unchangeable, and that give us the equation like this. And this is known as a new constant, and the phi constant, which explains, sorry, its position is here. That's how it looks like. And here we have just neglected the dark energy, and this will give us something like Neil Bohr's model. A model, let's say Neil Bohr model explains atom. This model explains energy levels of the universe. Let's say this is our mu v equals to 2, which is equals to Einstein's variables. But whenever we are talking about, sorry, here it is alpha beta because we are talking about 40. Because we are talking about a vector, to convert into alpha beta, we need to contract the v to give us mu 0, and that's the reason by contracted it we can feel its magnitude, and that's why the constants values changed from 2.070 multiplied by 10 power minus 43 to 7.33 multiplied by 10 power minus 171. And let's say mu vw is equals to 3, it will give us 6.2 multiplied by 10 power minus 256, and this process will goes on until we reach the ninth indice explaining 11 d's equals to 7 pi multiplied by 10 power minus 767, explaining the biggest universe or biggest dimensions constant. Now this is explaining that what if we move from lower to higher, what are its effects on our energy level? Constant. Now in next lecture I will define its application on black holes, dark matter and dark energy, and how it is related to entanglement, infinity, etc. Thank you.